Hello everyone, welcome back to my channel Easy and Inspire. In previous session we have seen JK flip-flop. In today's session we are going to discuss about master-slave JK flip-flop. Listen, master-slave JK flip-flop. So it is nothing but modified version of JK flip-flop. So before going to this topic, we'll see what is a JK flip-flop once again. So this is about JK flip-flop. So JK flip-flop is nothing but, so it is modified version of SR. Listen, JK flip-flop is modified version of SR flip-flop. In SR flip-flop, so there is one invalid condition. When S is equal to 1, R is equal to 1. So this results invalid conditions. So to overcome this problem in SR flip-flop, we are going to JK flip-flop. So in JK flip-flop, when J is equal to 1, K is equal to 1 and clock is equal to 1. So at this condition, when J equal to 1, K equal to 1 and clock is equal to 1, then it results toggle condition like 1 0 1 0 1 0 and so on, or 0 1 0 1 and so on, like this. So toggle condition occurs only when J equal to 1, K equal to 1 and clock is equal to 1. This is the condition. So this is about JK flip-flop. We have already discussed this. So if you want to listen once again, so look here. Okay, now we will see what is a problem in JK flip-flop. What is the problem in JK flip-flop and why we are going for master-slave JK flip-flop. Here I have mentioned the problem in JK flip-flop. Listen carefully. The problem is nothing but race around condition. So JK latch or JK flip-flop both are having race around condition as a limitation. So race around condition is different from toggle condition. Toggle condition occurs when J is equal to 1, K is equal to 1 and clock is equal to 1. We know this one. So toggle condition occurs when J equal to 1, K equal to 1 and clock is equal to 1. So same condition I am taking here. Clock 1, 0, 1, 0. Consider I have applied J is equal to 1 and K is equal to 1. So I am considering like this. And clock is like this 1, 0, 1, 0. So when J equal to 1, K equal to 1, clock is equal to 1. The output is going to change like this. Toggle like this. 1, 0, 1, 0. So in this duration, the output is changing from 1 to 0 and 0 to 1, again 1 to 0 like this. So within a single time period, listen, within a single clock period, the output is varying here. So it is not a constant value. So this type of output values are not considered, not accepted in any electronic application or electronic devices. So listen once again carefully. Within a single clock period, the output is changing from 1 to 0, 0 to 1 and so on. So multiple outputs are occur. So this type of conditions are not acceptable. So this is called as race around condition. Again you can check here J1, K1 and clock 1. So 0, 1, 0, 1. So multiple toggles or multiple outputs. So this type of condition is called as race around condition. So to eliminate this problem, we are going to master-slave JK flip-flop. Here I have mentioned two steps or two different conditions to avoid race around condition problem. So first one is by taking the clock less than propagation delay. So by just taking propagation delay into consideration. So it can be achieved by edge triggering. We have already discussed what is edge triggering in previous sessions. So this is first one. So second method is nothing but, so by taking master-slave JK flip-flop. So I'll explain what is a master-slave JK flip-flop in next slide. So here consider edge triggering. So this is positive edge. This is negative edge. Again positive, negative. You can consider this or this in edge triggering. So here it is level triggering. See here, high level, low level. This is master slave JK flip flop. So if you observe this carefully, master and slave. So two words. So I need two flip flops. So master slave, either JK or D, T, SR, whatever the flip flop may be. If you see the word master slave, so you need to consider two flip flops of the same type. So here I am taking two flip flops, JK flip flops. So one flip flop is acting as master, second one is slave flip flop. So master slave JK flip flop is having two flip flops connected in series. So both are in series. So in which first flip flop outputs are given as input to second flip flop, and second flip flop outputs are given as feedback to the first flip flop. So remember, so first flip flop outputs are given to second flip flop. Second flip flop outputs are given as feedback to first flip flop. This is master, this is slave. So this is master slave JK flip flop configuration. So master slave JK flip flop I have mentioned, the output of master is given to slave as input. The output of slave is given to input of master or feedback input of master. Clock pulse is directly given to the master. Listen here. Clock pulse is directly given to the master and clock is inverted here. See, clock is inverted and inverted clock pulse is going to the slave. So clock is directly going to master, inverted clock pulse is going to slave. So this is one more condition. So next one. So it used to eliminate the race around condition. So master slave JK flip flop is used to eliminate the race around condition in JK flip flop. We will see how it is going to eliminate. And it also imitate the function of, listen, it also imitate the functions of SR, clocked SR, D and T flip flops. So whatever the other flip flops, all the other types can be designed using this master slave JK flip flop. Remember this point, very very important. This is how a master slave flip flop is constructed. So master slave JK flip flop. Here I am taking one master JK flip flop, one slave JK flip flop. Always remember, once again I am repeating. So master slave JK flip flop is having one master flip flop, one slave flip flop. Either it is D or T or RS, whatever it may be. So master slave means two flip flops you need to mention. Okay. So this one is master flip flop. So this one is master flip flop. This one is slave flip flop. So if you observe, this is latch. So what is the difference between flip flop and latch? Flip flop is having a clock pulse. Latch do not have a clock pulse. If you observe this circuit do not have any clock pulse. Only this point. Again here, if you observe this one, so no clock pulse. So these two are master latch, slave latch. No need to mention these two, just I am mentioning for your understanding. So this is master flip flop, this is slave flip flop. Both are JK flip flop. And again observe here, clock is directly going to master. So when clock is equal to 1, master flip flop is activated. And when clock is 1, it is going to be 0. So because it is inverted here. So 0 means it is not activated. When clock is 0, so this circuit is deactivated and here it becomes 1, then this circuit is activated. So this is the operation. Listen once again. When clock is 1, the circuit is activated and here you will get outputs. So these two outputs are given to this slave input. Okay. So here it is 1. So inverted clock, 0 is going to this point. So 0 means it is deactivated. No change in the outputs. Whenever clock is 0, then only this circuit is going to be activated. So final conclusion is master slave JK flip flop. When master is, when clock is 1, then master flip flop is activated, slave is deactivated. When clock is 0, then it is deactivated and here it becomes 1. So it is activated. This is the final conclusion. So you need to understand this point very well. Okay, here I'll explain the operation of master slave JK flip flop. We know the main problem is when J equal to 1, K equal to 1, clock is equal to 1. Then only we have seen race around condition. Race around condition. So this is what our output is. So we have already seen. So this is our output in race around condition. So J equal to 1, K equal to 1, clock is equal to 1. So just I have considered only this problem. So remaining conditions like J0, K0, 0, 1, 1, 0, I am not considering here. So J equal to 1, K equal to 1, clock is equal to 1. So we know that when clock is equal to 1, the first flip-flop is activated. This clock is inverted here and 0 is going to this clock. So 0 is going to this circuit. So it is deactivated. So there is no change in the output when 1 is applied to the clock. When 0 is applied, so 0 is going to this 2. So it is deactivated. And 0 becomes 1 here. 1 is going to this point. So it is activated. When 0 is given, means nothing but when 1 is there, so master is activated, slave is deactivated. When 0 is given, this is 0. Master is deactivated, slave is activated. So then output is generated here. Okay, I'll explain here. Just listen. J equal to 1, K equal to 1, clock is equal to 1. So we don't know the previous values. Just I'm considering like here it is 0. Consider just 1. 0 and 1 I'm taking. Okay, this 0 is going here. 1 is going like this. 1, 1, 1. Again 1, 1, 0. So listen. 1, 1, 1, 1, 1, 0. I am just giving 1, 1, 1 to this one. It results 0 here. It results 1 here. So 0 is 1 input. 1 is 1 input. We know NAND gate. So NAND gate means 0, 0, 0, 1, 1, 0, 1, 1. NAND. So 1, 1, 1, 0. This is my truth table. This is my output. So first input is 0. Whatever the other input may be, it results 1. So 1 here I am placing. So 1 and 1, it becomes 0. We have already discussed all this. So 1, 0. 1, 0 are going to this second circuit. But here it is, clock is 0. So it is deactivated. So 1, 0 are given, but it is deactivated. So outputs are same, 0 and 1. Okay, for clock 1. Next clock is 0. I am taking 0. So when clock is 0, the first circuit is deactivated. No changes. So this 1 is going here, 0 is going here, and 0 clock here it becomes 1 and it becomes 1 here. 1 and 1. Again here 0 and 1. 1, 1 results. Listen, 1 and 1 given to NAND gate. It results 0. 1 and 0. 1 and 0. It results 1. So we know 1 is 0. Whatever the other input may be, it results 1. 1 and 1. It results 0. So if you observe this carefully, during the clock pulse 1, so output is 0 and 1. Nothing but no change condition in the slave. Previous past output is, this is the past output. When clock becomes 0, then this output is going to change. So toggled. 0 is going to 1, 1 is going to 0. Again second time it becomes so 0 and 1. again 1 and 0. So this happens only once, during the whole time period. Listen carefully. This transition or this toggle happens only once during the entire clock period. This is our total time period. During the total time period, transition is happening only once. Okay, let's see how it is going to be. So here I have explained. Okay, so this is my clock pulse J, K, clue. So from this operation, so I am drawing this timing diagram. Clock becomes 1 here, again 0, 1, 0, 1, 0. The final conclusion, what we observe from the above operation is, when clock is 1, master is activated, slave is deactivated. When clock is 0, master is deactivated, slave is activated. So the final output is at slave. So slave activation is important for us. So slave is activated only when clock is 0. So at this point, again at this point, at this point, so this point. So these are important points for us, because when clock is 0, then only output is changed because slave is activated. So J is 1, K is 0, clock is 1, no change. So because no change in the output. Next, clock is 0 here. J is 1, K is 0. So J1, K0. It means output set. See? So to understand this operation, J1, K0 and slave is activated here. To understand this operation, you need to observe JK flip-flop. J1, K0 means output 1. Okay. So output is going to be continued until next 0, because next 0 at this point slave again changes its values. So it changes means nothing but toggles. So here it is 1. It becomes 0 here. Again at this point it is going to be toggled. Again at this point, see here, J is 1, K is 0. J1, K0 means set. Already it is in set condition. So no change here. So you need to understand this carefully. At this point, J is 0, K is 1. Resetted. At this point, J is 1, K is 0. Setted. 1 and 0. So already set. So again it is setted. So again here, J is 0, K is 1. Means reset. So just go through this JK flip-flop and then understand master slave JK flip-flop. So all these operations, J0, K1, J1, K0. So what happens to the output? You will observe in JK flip-flop. So this is about timing diagram. If you observe this carefully, this output is going to be changed only once during the entire clock pulse. See, again this is the entire clock pulse. Once it is changed, again once. So no toggling like this. So we just avoided race around condition using master slave JK flip-flop. So these are the remaining operations. J0, K1. So J means set, K means reset. It results reset condition. So see, reset. J1, K0, set, reset. It results set condition. J1, K1, toggle condition. We know already. J0, K0 means that is nothing but no change condition. Same as JK. Here toggle condition is occurred like this. So see, this is toggle condition. But this toggle condition is accepted here because the entire clock pulse is having only a single toggle. Okay, this is about master slave JK flip-flop. Here I just given a route map for you people. So if you want to understand the flip-flops, first you need to learn sequential circuit, then latch and flip-flop introductions, differences, then SR and D latch. So again, differences between latch and flip-flop. So because here we have already seen latches. So why we are going for flip-flops? So for that we need to discuss differences. After that, different types of flip-flops. So understand the concept and what is the need for each and every flip-flop. You need to understand the operation, how it is going to be obtained, how Q is obtained, how Q bar is obtained, and what is the truth table, what is the characteristic table, what is the timing diagram. All these points you need to understand. Then finally, you need to know the applications of flip-flops and latches. So this is the process to study the flip-flops and latches. So in next session, we'll discuss about T flip-flop. That is nothing but toggle flip-flop. Okay, thank you.